All right. So this one is on routers, switches, as well as modems. I'm gonna throw in modems in there, as I've said in the previous video. So routers and switches, these two are networking devices which control how data flows through networks. So these two, they're part of the network infrastructure that I introduced previously. So I'm gonna start with routers, then followed by switches. So routers are essentially networking devices that forward data packets to different networks. So I'm gonna explain what these data packets are. I remember I introduced them first in when I spoke about data network or high speed data networks. So these these data packets are forwarded by switches through different networks, and routers play or perform certain functions when it comes to this network infrastructure. First of all, they have to read IP addresses. Remember, I said that every data packet contains IP addresses or contains a source address, IP address, and a destination IP address. So the router or the router reads IP addresses from data packets. After doing that, it determines what is the best path or the best possible path for data transmission. Right? I'm going to explain what how that is done soon. Right? So routers, they also connect local area networks or your LANs um, to wide area networks called your WANs, right? And they also connect users to the internet. So those are routers. And routers, when it comes to the OSI model is a 7-layer model or framework which helps us to understand how data moves through or how data moves from one device to another over a network, right? So it has 7 layers. In the first layer would be the physical layer, which is layer one. The second layer is your data link layer, and then followed by your network layer. Um, the fourth layer is the transport layer. The fifth is the session layer, and then followed by the presentation layer, and then finally the application layer. So in the OSI model, where routers operate, they operate in the third layer, which is the network layer, right? So how does the routing or the routing process go about? Because these routers, they route data packets throughout different networks. So a packet arrives to the router, and then the router has to check the destination IP address, as I've mentioned earlier, that the data packets contain source and destination IP addresses. So it has to check in the first step of the routing process, it has to check the destination address, that is to say, where is the packet going. And then after checking the destination address, it then has to consult a routing table or a routing table. I don't know how to pronounce routing, or is it routing or routing? I don't know how to say it, but you get the point. Um, so it then consults the routing table, and the routing table is basically, you can think of it as a list of rules, or a set of rules which are stored in the router. Um, or in a computer, that tell it where to send the network data packets next so that they arrive at the correct destination. So that's a routing table. So the router has to consult that routing table to determine where the data packet needs to be sent next, right? After doing that, and then it has to select the best available path from from the routing table, and finally it forwards the packets or the data packets to the next network. So that's how the writing process or the routing process goes about, and this routing of data packets, right? So the routers or the router uses certain protocols. We have a few protocols like the OSPF protocol, which is known as the Open Shortest Path First protocol. And then there's another protocol which is known as the border gateway protocol, and that's usually critical for internet backbone routing, right? So that's the routing part, that networking device, which forwards data packets to different networks. And now onto switches. Switches similar or somewhat different compared to routers, and what they do, a switch essentially connects devices within the same local area network, or within the same LANs, no, LAN, right? So those are local area networks, connects those devices within the same area network and perform several functions as well, such as forwarding packets. It also forwards packet, but it doesn't use IP addresses. It forwards packets based on MAC addresses. A MAC address is a media access control address, right? So it forwards data packets based on the MAC address. The switch also reduces network congestion so that there isn't too much traffic. And then finally, it allows multiple devices to communicate efficiently. The devices which are connected within the same local area network. So switches, in terms of the OSI model, where do they operate? Well, they operate in the second layer, and the second layer is the data link layer. So, but the modern switches that can also operate at the third layer, that is the network layer. So when you compare switches to routers or to routers, switches usually connect multiple or devices within the same local area network, and they use like MAC addresses instead of IP addresses. Whereas on the other hand, routers, they they connect different networks, and they use IP addresses. They don't use MAC addresses. And then there are modems as well in this network architecture. So I've mentioned routers, I've mentioned switches, and now onto modems. A modem is essentially stands for a modulator demodulator device, right? That's what a modem is. It says modem to mean modulator demodulator. So it's this device that converts digital signals into a suitable form for transmission over a communication channel or communication network, and vice versa. So that's how it works, right? So the reason why modems are important, devices are essential. You you know that different transmission media uses different transmission signals or signal types, right? So your transmission media, as I've mentioned previously in the previous videos, go check them out. That you have different transmission media, like your copper telephone line. Those are DSL lines. Your cable lines, your fiber, as well as your wireless transmission, right? So a copper telephone line would use analog signals, right? And cable lines would use, on the other hand, they would use radio frequency signals, and then you would have fiber. Fiber, on the other hand, uses light signals, and finally, you have wireless um, transmission, which uses radio signals or radio waves, right? And also remember that a computer uses computers use digital signals, which are binary zeros and ones. So a modem essentially converts between digital signals and transmission signals. All those transmission signals, the radio frequency, the light signals, the radio waves, including the analog signals. So it converts between digital signals and these transmission signals, right? So that's why we need modems. That's why they're important in the network infrastructure, because there needs to be conversion of signals, right? The different types of modems. You have DSL modems. I've mentioned that DSL modem in the broadband technologies. I've also talked about cable modems. What I did not mention, rather, is the fiber optical network terminal, which is another modem, right? And they also have cellular modems as well. So there's four different types of modems: DSL modems, you have cable modems, you have fiber, optical network terminal, and then there is cellular modems. So the DSL modems, they convert, you know, digital signals onto analog signals, and then your cable modems, what they do is they work with, coaxial cable TV systems or TV infrastructure. Remember, cable internet uses coaxial cable TV infrastructure. Remember that. And your fiber ONT or optical network terminal actually converts, light signals onto electrical signals. And then finally you have your, how do you call this, your cellular modem, which connects to mobile networks, right? And those mobile networks are SIM based. So when you compare a modem versus a router, a modem actually connects your home to your ISP or your internet service provider, and whereas the router actually distributes internet connection uh, to multiple devices in your home. So, but you'll find that many homes that they combine modem and the router into one unit. So you will realize this. The next one will be on, submarine cables as well as data centers. See you next time.